16. It said 17 on there, but this is the right one. Okay, the first one's what we're supposed to do is find the area of a regular polygon, round your answer to the nearest tenth. So I draw the same little triangle. See, I draw the same triangle on each one. It's just the angle changes. The first one is a hexagon, and because it's a hexagon, let me see if I can zoom in here so you can see it a little bit better. Because it's a hexagon, that's going to be a 30, 60, 90 triangle, because the central angle in a hexagon would be 6 into 360, which is 60, divided by 2 would be 30, and the angle at the bottom would be 60. They give us the length of the side. The length of the side is 4. So if the whole thing was 4, it's been divided 2 and 2, so the apothem is 2 square roots of 3. And that's all we need on this one, that and the perimeter. So the perimeter would be 6 times 4, or 24. The apothem now is 2 square roots of 3. So the area is the apothem, 1/2. Now don't forget the 1/2. Some people left those things off, other formulas, when they took their last test. So 1/2, the apothem, 2 square roots of 3, times the perimeter, 24, is 24 square roots of 3, or 41.6 meters squared, because it said round your answer to the nearest tenth. So that's a hexagon. Hexagons are easier because they have special right triangles. The next one says it's a pentagon. So here's my pentagon over here. It's 5 into 360, which is 72, divided by 2 would be 36. They tell us the length of the side is 10, so this side was 10, so it's 5 and 5. So to find the apothem, I have to use tangent. The tangent of 36 is a over 5. I mean 5 over a. 5 over a. Set it upside down. So 5 divided by the tangent of 36 is 6.9. 5 divided by the tangent of 36 is 6.9. I'm just going to check that. 5 divided by tangent of 36 equals 6.9. 6.88, 6.9. So that's my apothem. Then the perimeter, since it's a 5-sided polygon, would be pentagon. 5 times 10 is 50. So here's my formula. The area equals 1/2 the apothem, 6.9. Of course, you may not have did the rounding, but 6.9 times the perimeter 50, and I got 172.5 inches squared. So see, in the picture, the only thing that's different is we had to find the angle, which is pentagon, 360 divided by 5, and then divide by 2 to get that angle. The next one, this one it involves more trig, because this time we have a nonagon, 9 sides. So 9 into 360 was 40, so it split those into 20 and 20. Okay, and it says that the radius is 6, so the radius is 6. So this time I have to find half the length of the side x and the apothem 5. To find the apothem, we use cosine. The cosine of 20 is a over 6. So there's cosine 20. A over 6 is 5.6, is what I rounded my apothem to. To find half the side x, the sine of 20 is x over 6, and I got x is 2, so the sides would be 4. Okay, so the perimeter would be 4 times 9, which is 36, and then when I'm ready to plug it in, I got the apothem, so 1/2 of the apothem, 5.6, times the perimeter 36, and I got 100.8 feet squared. Now, if you didn't do any rounding, like if you didn't round here or didn't round here, and you just took this value, multiplied it times 9, that would have given you the perimeter with probably the decimal value, multiplied it times that one without rounding, and then it would be a little bit different. But I just left it as 100.8 because since we're doing these like we are instead of in class, I let you round and then solve. The next one, this one was a decagon, 10 sides. So a 10-sided polygon, that triangle would look like this. 10 into 360 would be 36, so it would be 18 and 18. The radius is 5, so we have to use sine and cosine again. Cosine to find the apothem, cosine of 18 is a over 5, so 4.8 is what I rounded it to. For the length of the side, the sine of 18 is x over 5, and I got 1.5. So if that's 1.5, the length of the side would be 3, and so over here I said the perimeter would be 10 times 3, which is 30. So I've got the apothem is 4.8, the perimeter is 30, so 1/2 the apothem times the perimeter, it came out to be 72 millimeters squared. 72 millimeters squared, that's what I got for the answer. Okay, so that would be number 4. These next problems are just find the area of a triangle using side, angle, side. Sorry about that. Side, angle, side. So It's a simple formula. Again, don't leave off the 1/2. 1/2 is in most of our formulas. So it's the area is equal to 1/2 the two sides multiplied the sine of the angle. So 1/2 of 6 times 4 times the sine of 68 is 11.1 meters squared. And we use that a lot when we're using the triangles for finding the area of a segment in a circle. Okay, the next one, same thing, 1/2, 11 times 12, sine of 33, and it's 35.9 inches squared. And the last one of those, it's 1/2 of 14 times 5, sine of 25, and I got 86. So those are fairly simple problems. Now the next is a word problem, and it was a little bit complicated. Ooh, I keep zooming in. It says the cost of finishing a floor is $2.50 per square foot. So we got to find out how many square feet we have, and what are we doing? It's a hexagonal floor with a radius of 5.5. So it's kind of like the problems we did up there at the top a minute ago. Let me zoom in on this though. Because it's a hexagon, remember the angle at the top here is 60. So these are 30 apiece. So it's a 30, 60, 90. So if the radius is 5.5, half of that would be the short leg, 2.75, and then the apothem would be 2.75 times square root of 3. So the apothem is 2.75 square root of 3. The perimeter, of course, in a hexagon, the length of the side and the radius are the same, so it's 6 times 5.5 or 33. So there's my apothem, there's the perimeter, so we can plug it into the formula. 1/2 the apothem, 2.75 square root of 3, times the perimeter 33, and it was 78.6 square feet. Now to get the estimated cost, we just multiply that times $250 per square foot, and I got $196.48. So that was the final answer. That was number 8. Okay, the next problems we'll zoom out so we can look at the circles and put the measures in them. What I did first is, well, this one is just naming parts. So it says name the center of circle A. Well, the center is what it's named by, A. A would be the center. A radius, or segment AE. Segment AE here is a radius. What is segment CF? CF is a diameter. It goes all the way across. DF, arc DF, arc DF. Arc DF is less than half a circle, so it's a minor arc. Arc CEF, and remember you go around it, CEF around this way, that's a semicircle because this is the diameter, it splits it into two halves. That, CEF and CBF, so those would be semicircles. That's 2 of the semicircles we can name in this circle. We actually name more than that. And then DBE, D, B, all the way to E, D, B to E. Of course, that's a major arc, it's more than half the circle. Okay, the next problem's fairly simple. What I do is first put all the measures I can on the circle, then I answer the questions. Since that angle was 114, that arc is 114. Since that angle is 90, that arc had to be 90. The angle beside it would have to be 90, and that arc would be 90. And the only thing I got left is this one, 66, because 114 from 180 is 66, so that arc is 66. And then we do a combination. UT, we already got it, it's 114. ST, we got that 66. VST is 66 and 90 is 156. VUT is 90 plus 114, so it's 204. SVT, all the circle except 66, so 66 from 360 is 294. USV is everything but 90 degrees, 270. All but 90 of the 360 anyway. And then UTS is a semicircle, it's 180. And then this one was all but 90 also, VUS, and so that was 270. Same thing on the next picture. You're answering questions about angles or arcs. And on this one, to start with, all we had was this arc was 70. Of course, I know that angle will be 70, that angle will be 70 because they're vertical, and then that arc has to be 70 because its central angle is 70. Well, if these are both 70, that has to be 110 because 70 from 180, so that arc is 110. That means that this angle would also, I mean, this angle here, the whole thing would also be 110, so it's divided in two, 55 and 55, so the arcs are 55 and 55. So then when you answer the questions, they ask for angle EDI. EDI, that's 70. Arc EF is 110. We've already got it on our picture. GI is also 110 because it's 55 and 55 on our picture. IDF, angle IDH. IDH, and we got 55 degrees for that one. And we got the arc FHE, F to H to E. It's all but 110. You can add all these together, or you can say 360 minus 110, so it would be 250. And the last one, arc GIF. GIF is 360 minus 70, so it was 290. These at the bottom, you just have to find, using algebra, solve for the variable. So we're going to say this plus this equals 180, because there's a diameter, so these two angles have to be 180. So add them together, set them equal 180, and I got A is equal to 75. All of these angles, this one, and this one, have to add up to be 360. So the sum of those angles is 360, so I got A is equal to 15 on that one. Okay. The next two, just find the circumference. Circumference is either 2 pi r or diameter times pi. Here they gave me the radius, so it's 2 pi r, so 9 times 2 is 18 pi meters. Now it's a length, so it's just the unit, it's not units squared. 32 is 15 pi, because the diameter is 15 pi centimeters. And the last one, we have to double 5.8, we get 11.6 pi inches. 11.6 pi inches. All right, so that's circumference. On the other side, number 34, we have to find the length of an arc. Okay, the length of arc. LOA, I'm calling it length of arc. Okay, that's what I'm, little o always of, so length of arc, length of my arc. And it's a fractional portion. Now it says the darkened arc, and this is the darkened arc right here that has 20. So you have to take the angle measure, which would be 20 over 360, it's 1/18 of the length of the circumference, the length of the circumference. Circumference in this case will be 2 times 9, 18 pi, because the 2 radiuses times pi, or the diameter times pi. So 1/18 of 18 pi would just be pi. That's how long it is. It said leave in terms of pi, so pi inches. And remember, that's a length, so it's not squared. The next one, 120 over 360, and that's going to be 1/3 of the whole circumference. And the whole circumference, since they gave me diameter this time, is just 15 pi. So 1/3 of 15 pi is 5 pi. That's how that one worked. And the next one, the angle is 180, because it's half a circle, it's a semicircle. So 180 over 360 is 1/2 of 22 pi. 22 pi would be the circumference, so 11 pi is the length of that darkened arc in that one. Okay. All right, these next ones, we are dealing with area now, and the area of a sector, just like on the worksheet, is a portion or a fraction, just like up at the top. Length of an arc is a fraction, a portion of the circumference. This is a fraction or portion of the whole area. So what fraction? 90 over 360, that's a fourth. A fourth, and for the area of a circle is pi r squared, so pi times 4 squared, so a fourth of 16 pi is 4 pi, and I put units squared since we didn't have any units. The next one is 36 over 360. 36 over 360 is 1/10. The radius is 6, so 6 squared is 36 pi. So 1/10 of 36 pi, I just left it as 18 over 5 pi. 18 over 5, because I reduced 36 over 10 to 18 over 5, divided by 2. The next one, the angle is 300. See, we're looking for the darkened arc, this part. So we subtract 60 from 360, we get 300 for the arc. 300 over 360, which is 5/6. And the area would be pi times 6 squared, or 36 pi. So 5/6 of 36 pi is just 30 pi. 30 pi. Because 6 will go into 36, 6 times, then times 5 is 30, so 30 pi units squared. And this last one, the angle is 45, so 45 over 360, which is 1/8. The radius is 10, so 10 squared is 100 pi. So 1/8 of 100 is 25 halves, so 25 halves pi, or that'd be 12.5 pi units squared if you wanted to change it. Then we're doing area of segments. So that's the area of a triangle, the area of the sector, this whole sector here, like we were doing up there, those other problems, find the sector. And then we'll subtract the triangle. So the sector is 90 over 360, which is a fourth of the whole area, and the whole area would be pi times the radius squared, so pi times 3 squared is 9 pi. So a fourth of 9 pi, we'll just leave it 9 pi over 4 for now. We have to put these in the nearest tenth. So 9 pi over 4 is the area of the whole sector. Now the area of the triangle is real simple. It's 1/2 3 times 3 sine of 90. Remember, that's 1/2 BC sine A, or AB sine C, or however you want to look at it, the two sides. See, if that's 3, this is 3. All radii are the same in a circle. So these are 3 and that's 90. So that's a side angle side situation like we had on the front of the paper. So 1/2 3 times 3 sine of 90. Sine of 90 is 1 anyway, so it's half of 9 over 2, or 4.5. So then to get the segment, we have to say the sector 9 pi divided by 4 minus 9 over 2, and the answer was 2.6, and it's units squared because we don't have units. So we do the same thing on each one. First we got to find the sector, 60 over 360, pi times 5 squared, 25 pi. So 25 pi over 6 is the area of the sector. The area of the triangle, again, using that formula, 1/2, 5 times 5 sine of 60. And I got 25 squared roots of 3 over 4. So you got to punch that in your calculator. 25 pi minus, 25 pi divided by 6 minus 25 squared roots of 3 divided by 4. And I got 2.3 units squared. 2.3 units squared. And the last one, since this is 60, this angle had to be 120 because they're supplementary. So 120 over 360 is the area of this whole, the angle for the sector, times pi times 4 squared, because the diameter is 8, the radius will be 4. So 16 pi, a third of that, 16 pi over 3. Okay, and I just leave it that way until I get ready to punch in to get it in decimal form. For the triangle, the angle is 120. The two sides will be 4. See, this is 4. And that's 4 because they're the radii. You just got to remember that. It's something that people forget a lot, is that the radius is always, the radii are always the same. I don't know why. And anytime, if we drew a radius anywhere else, if I want to draw a segment from here to here, it would still be 4. Okay, so people seem to forget that sometimes, but that's kind of handy, and they take advantage of people sometimes with these problems, making you think. If you don't think about that, you'll miss them. So anyway, the area of the triangle is 1/2, 4 times 4, sine of 120, and I got 4 squared roots of 3. So the area of the sector minus the area of the triangle, and 9.8 was the final answer. The last 3 problems at the bottom were just kind of, just throw those in there. They're a little tricky. You've got to do one area minus another area, or you just got to look for a strategy, and that's what geometry is supposed to be about anyway, how to think through and solve a problem. So on this one, we have 2 sectors that are the same. So I'm just going to find one sector and double it. Its angle is 50 over 360. The radius is 30, so pi times 30 squared. So 900 pi is the area of the whole circle. 5/36 of it is the area of this one sector. So it ended up being 125 pi, but there's 2 of them. So times 2 is 250 pi. 250 pi, and this is centimeters, so it's centimeters squared. And I wrote it as 785.4 centimeters squared instead of leaving it in terms of pi. The next one, we don't have to do circles. It's not pi at all. We just use 2 squares. The large square will be 10 times 10, or 10 squared is 100 millimeters. The smaller square is 7 times 7, or 49. So 100 minus 49 is 51 millimeters squared for the area of the shaded region. Now you could have found the area of the triangle and multiplied it times 4, but that would be silly. We could have done, say 5 and 5, and that's 90. We could have had 1/2, 5 times the sine of 90, or 1/2. Of course, that would have been, it would come out just a little bit different when we do our answer that way, just a little bit because of rounding. All right, and on this next one, we have to do the area of 2 different hexagons. Now, knowing that I'm going to draw this triangle, knowing that it's going to be 30, 60, 90, the apothem is half of the side, so it's going to be 4 square roots of 3. And the apothem in this one would be 2 square roots of 3. So, for the large one, 1/2 of 4 square roots of 3, 8 times 6 for the perimeter is 48. So 4 square roots of 3 times 48 divided by 2 is 96 square roots of 3. And for the small one, like I said, the apothem would be 2 square roots of 3. So 1/2 of 2 square roots of 3 times 4 times 6 is 24 for the perimeter. and I got 24 square roots of 3. So the shaded region will be the large one minus the small one. So 96 square roots of 3 minus 24 square roots of 3, or 72 square roots of 3, or 124.7 feet squared. So those are all the answers on the study guide. And as I said, or I told my other classes, we're not having any more tests. Study guides are a review of the work that we've done in these last 2 sections. So we're not going to have any more tests because all the printing and then I can't give them back. I always think of a test as a learning tool. Once you make a mistake, if I get back, then you learn from that. But I can't give these back. All I can do is show you your scores. So I can't scan all those back in with my notes and everything and give them back. That would just be too much, and so that's why I don't feel like it's going to be necessary that we have any other tests. Just do these problems, because these problems are going to come in handy. They're teaching you strategies of solving problems, and they're definitely going to come in handy when you go on. Math is cumulative. We keep using what we know about how to solve special right triangles. The Pythagorean theorem is going to show up. All these different things that we've studied, and this just reinforces that, getting you better prepared for your for the ACT when you take it, getting you better prepared for Algebra 2 as well. So that's that study guide.